Hi, my name is MinHsuan Peng. I'm with Wolfram Research. I'm a kernel developer in visualization. Today I will talk about core visualization. Thank you. So in the end of the talk, we will see that how did I make this plot, which consists of exclusions and, well, this one doesn't have scaling functions, but there's a callout and there's plot labels. It doesn't have the labeling function, but because it is the wrong plot to have that. But that's my goal for today. Okay, so for exclusions, Adam has talked about the core computation about how to find exclusions and the discontinuities. Here, I want to talk about what's the interface that when it applies to the visualization. Exclusions, this option is not a new option that we have added. This is probably since version 6, I think, yes. And, but we did extend the option values in version 11. That's the discontinuities and singularities. Thanks to Adam, these two presets can find different types of continuities. You don't need to worry about it anymore most of the time. And right, so this is kind of the famous plot, which is a tangent x. The central line in the at the poles are coming from the line between positive infinity and negative infinity. Previously, the algorithm couldn't find these poles automatically, so that we didn't remove it. You have to hand or manually specify where the positions you want to remove. So, but in version 11, okay, slideshow mode doesn't have the auto completion. So I hope I can type. Okay. So in version 11, automatic exclusions can remove the exclusions. And what is behind the scene is that when it comes, well, because of the exclusion code can find where the exclusions at. And behind the scene, when we are comparing that what's the sign of the function around that point. And if we find that if the signs change, then we just simply don't generate the lines at that point. So that's what's happening in the plot. And to show that it's actually get removed, you can specify exclusion style. Then you can see, then these are the lines where the exclusions at. So there are different types of discontinuities. This one is removable discontinuity that you don't really see it because they are only at the points. I can show that to you if I specify the exclusion style in a very dramatic way. Then, yes, the exclusions are there and has been removed. For the jump discontinuity, I did define a kind of like a cheating function, which is a piecewise function to create this jump. Again, the exclusion styles, after it is specified, then you can see where the jump happens. That's where it's get removed. Like I said, the nice thing about the version 11 exclusion is that this is all done automatically. Here I have a very complicated piecewise function. Then it consists of all sorts of different discontinuities. And then they can be found automatically. And those are the presets that I talked about. So if you want to know what kind of discontinuities that it happens, you can just change the different presets. Right, so this is the singularities. We can also find the branch cut, not exactly what Oleg was talking about, but for the 3D plots, this can be shown. And for the density plot and contour plot, this can be also detected automatically. Okay, next thing is scaling functions. This function, I think, has been there for a couple of versions already, but I think we started to make it more visible.
I think version 8 for the charts.
Right, version 8 for the charting functions, but we make it more visible for the plots in the post version 10, I believe. And in version 11, we complete this list. I want to talk about that, what happened in the previous versions. So in version 10.4, or 10.3 actually, we started to add the scaling functions to the list plot and list line plot. For some plots that both dimensions make sense, we will have scaling functions on each dimension or each direction. For example, this one, I only specified log on the x direction. And well, list plot is the same thing. And we also have the date list plot, which we currently don't support the log dates, mainly because of the anomaly of negative values, how we count the times. Yes. But here, I use the scaling function reverse on the y-axis. I think this is a nice feature that a lot of people have been asking about. Because of adding scaling functions, we pretty much make all these list log plot, list log log plot, list log linear plot, and then list log plot aliases. Yes, we have all of them. And in version 11, we extended the scaling function to the plot, which make log plot, log log plot, log linear plot aliases. And well, this is a small manipulation that you can see how they work. And our plan for the future is we will have the scaling functions come into the geographics plots and also for the 3D plots. So we kind of like doing this progressively. Okay, so what's been done behind the scene is actually, so for example, I have a plot which have poles at cosine x equal to 0. So if I really want to use the scaling function to transform this into something different, then there is nothing magical here. So we just define our scaling functions. The scaling function, for example, here will be just the inverse or reverted scaling function. And we apply that scaling function on the function itself first. Then pretty much the curve is what we wanted. But all these, the details, the framework, the ticks, and the grid lines, and the coordinate tools, they are still in the original domain. So this is just a demonstration conceptually that how we did it. So then because we need to convert back the ticks into the original domain, so we have to use the inverse scaling functions to find it. So here is what it looked like after changing the ticks. It may seem quite simple here, but believe me, it is huge work to figure out what the nice ticks should be, especially for the free-form scaling functions. Another main thing is the coordinate tool options. So if I do the command dot or control, oops. How do I get the coordinates? Oh, here, yes. Well, you probably can't see it, but here, there should be like a pair of values of the graphics. Because I haven't done any modification here yet, so they are the values in the transformed domain. Ideally, well, which is done internally, they have been inversed as well, so you will get these values correct. So these are just one other options that we handled here. But in the internal functions, we handle all the grid lines, the frantics, the epilogue, all the graphics options has been handled. Let me get back to. Okay. Next thing I want to talk about is wrappers labeled and call out. In 10.4 and before, we have added, I think the label wrapper for the charting functions is added when the charting functions were created. That was in version 7. But the idea to use the label wrapper is just labeled with the data and the label. So here there's a bar chart, and here is the label that I use, 1, 2, 3, 4. So that's simple. In the version 10.4, we decided to extend the label wrappers to the scatter plots, which is this plot. This is a very difficult problem, especially when the data set has some characteristics. For example, like this one, it kind of distribute along the diagonal lines. Then this is only like 15 points. If you have like 30 points, all distributed in the diagonal lines, they're doomed to collide. And how do you find the labels that's not colliding? That is a not so easy job. So I'm not saying that we have solved the problem 100% because, well, it depends on how many positions you can have the label at a point. This can be an NP-hard problem. So, but we have tried, and this is the results we have. They are there in version 10.4. This is another example under this line plot. We tag the lines between the points into the considerations, so the labels can avoid the collision with the lines as well. In the version 11, we added the support of labeled to the curves. So we wanted to make it really, really simple, so you don't need to worry about, the collisions. So the syntax is just like labeled. For example, this is sign divided by x, and the labeled and position. And this position, I really mean just one value. For example, like 4. What happens is that it takes that values in and compute what the y values should be of that label. And then it will put the labels, well, this take into a lot of considerations. For example, the length of the label and the image size of the graphics, and also the label style. If you have a huge label, then it will take that into consideration as well. Then we have a solution here that as long as you just specify a position, it will find a spot that will avoid the collision. In the version 11, we also added another thing called call out. There are still a lot of chances that, especially in the more complicated or more curved graphics, if you just specify a position like using labeled, they can be ambiguous. So we decided to use the call out, which has a leader line to show where the label actually refer to. The same thing we supported to the data points. As you can see, this is not 100% ideal yet, but we are working on that. Right. So someone has asked before that, how do you specify the call-out labels arbitrary, or what's the interface of it? So here I want to introduce to that. So there are a couple things to know about the callout label. There is the leader, which is this the slope line here, and there is something called neck that connects to the label. When you specify the position, you actually specify the position of this point, right? And just like labeled, when you specify, say that position is at x equal to 2, then it will try to find the position according to the function so that that callout label is not going to collide with the curve. Say again? So I didn't catch that. Oh, if I want the label to be vertical, yes, there are the options to set that. I will talk about that. Okay. So for example, here I only said that I want the callout label at point 2.5. So what's been decided automatically is where the y position is of the label, and also where the leader point to. So if you really, really want the fine control, like for example, if there is a certain feature of the curve that you want to point to, then you have to specify where the leader point to. That would be next example. Here I want to show you that it actually did put some effort to find where the free spaces are so that it doesn't collide. So here is a manipulation that I can show you. If I say that if I want my label position, it's actually will compute it, the y position according to where the leader is specified. Here it is not automatic, so that's why it remains at the same y position. But if you change the leader where it points to, then the y position will also change. And there are a whole set of options for callout, which, if I can type options of callout, right. Thanks to Tim, our graphics designer, that we have a set of appearance. This probably doesn't show much because it's too, oh, there we go. So this is the default, and there is a curve, the leader. And, well, I'm going to show just one, like balloon or slanted. Right. So, right. So, but you can also specify where the position of the label to be exactly at. So, for example, I want to say to be at this point. Then this is where you specify the label is. Well, if you also specify where the label, I mean, the leader points to, I mean, you can do that, but it doesn't, I mean, there isn't much difference from using just text if you do this. But, okay, for the data points, the callout, there is an option called the leader size that you can specify the length of the leader and the length of the neck. I probably won't see that, but if I, something like that, and you can do the neck rotation or the rotation of the whole leader. I'm going to make it automatic. Right, so here is all the detail controls you can have. Okay, the plot labels. Okay, I don't have much time here, but like Brett introduced, plot labels is there in version 10.4. What's good about it, which I think is pretty clever, is that when there are lines that's very close to each other, the labels will not collide again. Here, the collision is our enemy, so we try to avoid that. And this is what we have done. And all you need to do is just to, potentially you can say plot labels go to automatic. But in this case, they are the solution of this dissolve. They are awfully long, so I put something else. You can also say that I want the plot labels not just on the right-hand side, but along the curves. So here is your syntax that you placed, and the position, something like that. You can also use callout if you want. So callout works just like the place, the syntax. You can position them using the callout feature with all the details of the options we provided. The last thing is the labeling function. This thing is only implemented currently in the data visualizations. The charts and the list plot, list line plot, and we also have done that in the list step plot and daily step plot. These are the syntax, but I really want you to know that we have done a lot of automations here. For example, if your data itself contains some keys in association, then you don't need to specify any options, even labeling function itself. It will just automatically pick it up. And using the automatic labeling position, it will avoid the collisions, whatnot. So just to show you that if you have the confidence that if you place the label all on top of the points, nothing will collide, then you can do that as well. Otherwise, automatic will do that. We put a little bit of effort to make sure that, that if you put the labels at center, it can replace the points. Sometimes they are interesting and they are useful. But for example, like that. We also done that for the list step plot. Again, so this is more detailed control. I can use the callout to do the work. This is just to show you the arguments. The first argument is the value of the point. The second argument is the index of the point. The third argument is actually a collection of various label mechanics that we provide. So here I kind of sneakily just choose the last one, which is the keys for data. And here is a real example. Okay. Okay, where is? All right, the title of this slide is called Future Works. I don't know where it went, but we are currently working on the callout and labeled features in the bubble chart, which is another challenge because now we have to worry about the collisions with regions. And also, if you like the labeling functions in the timeline, we also extend that to the bar chart. That's something for the future. And for the stacked bar chart, a lot of people have trouble, to place labels when the bar is very small. So we also have similar solutions to like the plot labels for that. So that will conclude my talk. Thank you very much.